All right, let's get started on the third day of the mole composition unit. Today we're going to combine what we learned the first and second day, and we are going to be able to convert between those two, not just go from moles to particles or particles to moles, or from mass to moles or moles to mass. We're actually going to go from particles to mass, and it'll be a two-step problem. So if you'll remember at the beginning of the year, whenever we were doing the dimensional analysis and you were like, Miss, why can't we just skip one unit conversion and just Google what it is? And I said, you guys don't get the point. I wanted you to be able to do two-step conversions. And this is why. This is what I was wanting you guys to experience two-step conversions for. So, let's get started, and this shouldn't take long. We have one example. So the goal for today, I want you to be able to perform two-step conversions. So we're going from mass to particles or particles to mass. And remember, particles can be atoms, they can be molecules, or they can be a formula unit. Okay, so how we'll convert between moles and particles. We will use 1 mole equals 6.02 times 10 to the 23rd particles. So that's what we learned the first day. And then we learned that 1 mole is equal to the atomic mass in grams. And that's when we found out how much each of these atoms in the molecule weighs. And we found out its molar mass. So that's how we converted between moles and molar mass. So today we're going to convert particles to mass, or we're going to convert mass to particles. And we're just going to use those same conversion factors. So it'll always be 6.02 times 10 to the 23rd. We'll always use that number to convert particles to moles or moles to particles. And then we will use molar mass, which is what we calculated yesterday in the notes, however much these weigh, to convert from mass to moles or moles to mass. So here is the example. And we'll just get started. So basically it says, what is the mass of 1.79 times 10 to the 24 formula units? So basically that many number of potassium phosphate, or K3PO4, how many of those molecules is what it's asking. So our known is the number they give us in the question, which is 1.79 times 10 to the 24 formula units of K3PO4. Okay, and then our unknown is just what the question's asking. It's asking what is the mass of this many formula units of K3PO4. So if we have this many formula units of this, how much will it weigh is what it's asking. So on the equation, we always start out with what our known is. So our known is 1.79 times 10 to the 24th formula units of K3PO4. And then we're going to multiply that by the conversion factor. And then we'll actually have one more. So I drew my line a little long, so that's going to be annoying. We'll just draw one big line, I guess, and that'll make it less annoying. Yeah, I can't do it. I have to separate it, sorry. There we go. Okay, and then this will be our conversion factor. Okay, so remember dimensional analysis, whatever is up here must go down here. So this will be formula units of K3PO4. And then up here, so we're converting from formula units to moles. We're going to need to convert to moles. So, because we'll use moles and convert that to mass. So we'll have formula units down here and moles up here. That's potassium, that's a K, sorry, K3PO4. And then whatever's up here will have to go down here. every single time we do dimensional analysis, just like we learned at the beginning of the year, whatever is here will go down here. Whatever's up here will go down here. So this will be moles of K3PO4. And up here will be what our unknown is. So up here will be, not mass, but grams of K3PO4. Because the unit is in grams for molar mass. So now we just fill in our numbers, okay? So for every 1 mole, okay, we're using the 6.02 Avogadro's number. So for every 1 mole of this stuff, it's going to weigh, we're going to have this many 6.02 times 10 to the 23rd. Every time we have a mole of anything, we have this many formula units or particles of this. Every single time. That's a conversion factor. That's just like saying for every kilogram, we have 1,000 grams. Okay, it's just a conversion factor. And then here, we have for every 1 mole, okay, so for every 1 mole of this, how much will it weigh? And that's what we did yesterday. We need to find out how much each atom weighs and then multiply it by how many of the atoms are in the molecule. So we're going to come down here and do a quick calculation of its mass. I'm going to move it here. So in the molecule, we have potassium, we have phosphorus, and we have oxygen. Okay, so we have 3 atoms of potassium. We have only 1 atom of phosphorus, and we have 4 atoms of oxygen. And now we're just going to multiply by how much they weigh. So potassium is here, and it weighs 39.098. Okay, and we only have 1 atom of phosphorus, which here, 30.974. And then oxygen, we know, is 15.999. We're going to add all of that together, and then that's our answer. So it looks like the periodic table, significant figure-wise, it's going to be 3 digits past the decimal, and on this periodic table. On the one that we use on the PowerPoint, they round it to 2 significant figures because they use a different periodic table, and that's okay. Just make sure you use the periodic table that's stapled to your test, like I have already said in the past. Okay, so calculator. Let's turn it on. 3 times 39.098. Turns out to be 117.294. Technically, because this is 5 and that's 6, you should probably take this off. But I'm going to leave it. Okay. So here we just bring this over, 30.974. And then 4 times 15.999, 63.996. We'll add them together. So the answer is 212.264. Now I'm going to go ahead and take this off. So significant figure wise, this is not going to round it. So we're going to take that off. And so for potassium phosphate, it weighs, for every mole of potassium phosphate, it's going to weigh this many grams. So 212.26, 212.26. And now all we have to do, we have our whole equation set up. We just type it in the calculator and we're done. I want you guys to see. Okay, so to type it in the calculator, I do it this way. There are many ways to do it, but this is how I do it to make sure I don't screw it up. 1.79 times 10 to the 24th. And since there's a 1 here, we ignore it, so we just do that divided by Avogadro's number, if I need to divide, divided by 6.02 times 10 to the 23rd. And then I divided. There's a 1 here, so we're not going to divide here. We're going to actually multiply. So times 212.26. So here to here, we're going to divide because it's on the bottom. And then we'll multiply because it's on the top. So if it's on the bottom, you divide. If it's on the top, you multiply. Always. And until we get to stoichiometry, there will be always a 1 somewhere. So you're either multiplying or dividing. If you want, you could do this number, parentheses, times 1 over this number, in parentheses, times, parentheses, this, equals, if you want. But it's going to be really long, and maybe your calculator might not accept that length of an equation, or you could mess it up, or you could even do it in your head if you are okay with dropping these exponents. Whatever you're comfortable with. If you wanted to drop the exponent, you could do 24 minus 23, and then the exponent is 10 to the first, but it's all up to you what you're comfortable with. This is what I'm comfortable with, and so that's what I'm sticking with. So the answer with regards to your significant figures, remember at the beginning of the year, we just always look at this one, and just that's what we go by. So there's 3 significant figures here. So we're going to round to 3 significant figures here, which is 631. So these units cancel, and we're left with these units. So 631 grams of potassium phosphate. And that's our answer.